equality of two ratios, the equality of two ratios, that is A is to B is equal to C is to D, that is nothing but A is to B is to C is to D is called the proportion. If the numbers of related terms lies within the 4, then this is called a simple proportion. A continued proportion is the one in which there is a chain of ratios between the related terms. If there is a chain of ratios between the related terms, then it is called a continued proportion. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class, we have discussed regarding the first part of the chapter, that is the ratios, the problems definition and different types of problems based on the ratios. Now today in this session, I am going to discuss regarding the second part of the chapter, that is proportions. So what are the things we are going to study in this session means, what is the definition for a proportion and different types of proportions and the properties of a proportion. So what is a proportion and different types of proportions and the properties of proportions that we are going to discuss in this session. Now let us know regarding what is meant by a proportion and with an example. Now the proportion is nothing but the term proportion may be defined as the equality of two ratios. The equality of two ratios is defined as the term proportion. So the equality of two ratios means, let us consider if A is to B, A is to B is equal to C is to D, which is usually a proportion, that is, and this is expressed as A by B is equal to C by D, implies if we cross multiply A into D is equal to B into C, or A is to B is to C is to D, that is, if A is to B, A is to B is equal to C is to D, then this can be written as A by B is equal to C by D, or A into D is equal to B into C. That is, A into D is equal to B into C, or we can also write A is to B is to C is to D. This is called the proportion. So that means the term proportion may be usually defined as equality of two ratios, the equality of two ratios, that is A is to B is equal to C is to D, that is nothing but A is to B is to C is to D is called the proportion. Now let us take an example, small example. So the ratio 2 is to 3 is equal to the ratio 6 is to 9, and hence it can be said that 2, 3, 6, 9 are in proportion. 2, 3, 6, 9 are in proportion because, so what is 2 is to 3? 2 is to 3, 2 is to 3 is equal to, this is equal to 6 is to 9. That means here 2 by 3 is equal to 6 by 9. If you multiply this, so 18 is equal to 18. 18 is equal to 18. That means the ratios, so 2 is to 3 is equal to the ratio 6 is to 9. Therefore, these numbers 2, then 3, 6, 9. 2, 3, 6, 9 are in proportion. They are in proportion. Similarly, move on to the next problem. State which of the following are proportion. What is given? 1 is to 3 is to 4 is to 5. So what is this equal to? 1 by 3 is equal to 4 by 15. So 1 into 15 is equal to 3 into 4. 15 is equal to 12. They are not equal. Right? This is not equal. Therefore, what do you say? It is not a proportion. Therefore, it is not a proportion. It is not a proportion. Right? Now let us take similarly. 7 is to 9 is to 14 is to 18. Then I will write 7 by 9 is equal to 14 by 18. 7 into 18 is equal to 9 into 14. So this is 126 is equal to 126. So what is it? Therefore, it's a proportion. It is a proportion. So the first one is not a proportion because 15 is not equal to 12. So this is 126 is equal to 126. Therefore, this is a proportion. Now move on to the types of proportion. So there are different types of proportion. First one is a mean proportion. What is mean proportion? Suppose if A, B and C are said to be in mean proportion, if A is to B is to B is to C. So that is, if A is to B is to B is to C, then we are going to call A, B, C are in mean proportion. That is, that can be written as A by B is equal to B by C. Just multiply this. A into C is equal to B square. That is, B square is equal to AC, or B is equal to root of AC. B is equal to square root of AC. That means B is the mean proportion. So if A, B, C are said to be in mean proportion, if B square is equal to AC or B is equal to root of AC. Now let us consider an example. If 1, 3 and 9 are in proportion, then 1 is to 3 is to 3 is to 9 is equal to, then what is the value of B here? So that is just B is equal to 1 into 9, that's equal to 9 square of 9 is equal to 3. So square root of AC, B square is equal to root of AC, that is B square is equal to A is 1 and C is 9, square of 9 is 3. So therefore 1 is to 3 is to 3 is to 9, that is 1, 3 and 9 are in proportion, right? Now move on to the next problem. Second type, the second one is the simple proportion. What is this simple proportion? Means when the numbers of related terms remains within the 4, if the number of the terms, if the number of related terms remains within the 4, it is a case of simple proportion. If the numbers of related terms lies within the 4, then this is called a simple proportion. For example, that is A is to B is to C is to D. That is, for example, 2 is to 3 is to 8 is to 12 is an example for a simple proportion. So that is, when the numbers related terms remains within the 4, then that case the numbers are said to be in simple proportion. For example, 2 is to 3 is to 8 is to 12 is in simple proportion. Now move on to the next one, compound proportion. Compound proportion. So when the numbers are related terms exceeds 4, the first one is, previous one is within the 4, here it is if it exceeds 4, when the number related to the terms exceeds 4, it is a case of compound proportion. So in case of compound proportion, the numbers related exceeds the 4. So for example, that is, if A is to B is to C is to D is to E is to F, then 2 is to 3 is to 8 is to 4, 6 is to 9. This is an example for a compound proportion. So if the number exceeds 4, here it is, A is to B is to C is to D is to E is to F is a compound proportion. Let us consider an example. 2 is to 3 is to 8 is to 12 is to 6 is to 9 is an example for a compound proportion. Now let us move on to the next one. Next one is continued proportions. Continued proportion means there is a chain of ratios. If there is a chain of ratios, then it is called a continued proportion. So a continued proportion is the one in which there is a chain of ratios. If there is a chain of ratios, then they are called as a continued proportion. So how to define a continued proportion? Is the one in which there is a chain of ratios between the related terms. If there is a chain of ratios between the related terms, then it is called a continued proportion. Now that is, if there is a chain of ratios means, that is, if A is to B is equal to B is to C is equal to C is to D and so on is called a continued proportion. That is, if this is, so A is to B is equal to B is to C is equal to C is to D and so on, then it is called a continued proportion. For example, 1 is to 2 is equal to 2 is to 4 is equal to 8 is to 16 and so on. This is an example for a continued proportion. Okay. Now next one, direct proportion. So what is direct proportions? Direct proportions means, a direct proportion means there is a positive correlation. There is a positive correlation between the related terms whereby an increase in the value of one followed by the proportionate increase in the value of the other. So the increase in value of one will follow the proportionate increase in the value of the other, and a decrease in the value of one is followed by the proportionate decrease in the value of the other. So whenever if you increase a quantity, then there is a increase. If you are going to decrease a quantity, then there is a decrease. So such a proportion is called the direct proportion. It directly depends on the increasing and decreasing. That means a direct proposition means a positive correlation. There is a correlation between related terms whereby an increase in the value of one is followed by the increase in the another, and similarly if there is a decrease in the value of one is followed by a proportionate decrease in the value of the other. So if there is a increase, proportionate increase is also there, and if there is a decrease followed by the proportionate decrease, in such a case the proportion are said to be direct proportions. Very important concept. See here how to define a direct proportion is a positive correlation between the terms whereby an increase in the value of one followed by proportionate increase in the other. Similarly, if there is a decrease in one value followed by the proportionate decrease in the other value, such a proportion is called as a direct proportion. Now, example for direct proportions are the ratio between the cost and quantity of an article. The ratio between the cost and quantity of an article is an example for a direct proportion. Similarly, the heights and weights of the person, the height and the weight of a person is also an example for a direct proportion. Next, inverse proportion. What is inverse proportions? Inverse proportion means a negative correlation. The first one is a positive, here it is a negative. A negative correlation between the two related terms whereby an increase in the value of one is followed by a proportionate decrease in the value of the another, and vice versa. So when there is an increase, it is followed by the proportionate decrease, and vice versa. Such a ratio is called as a inverse proportions. Very important concept. An inverse proportion means a negative correlation. It's a negative correlation between the two related terms which by an increase in the value of one followed by a proportionate decrease in the value of the another one, and vice versa is called an inverse proportion. Now what is an example? The example for this is the ratio between the number of workers and the amount of time. The ratio between the number of workers and the amount of time is an example for inverse ratio. Similarly, the ratio between the supply and the price. The ratio between the supply and the price is an example for this inverse proportion. Let us move on to the properties of proportion. Properties of proportion. Now, first property, inverted. So, inverted means just reciprocated. That's it. Let us take the proof for this. Proof. What is actually? So, inverted means if A is to B is equal to C is to D. If A is to B is equal to C is to D, then inverted is nothing but inverse, just reciprocated. B is to A is equal to D is to C. So that is B is to A is equal to D is to C. Now let us move on to the proof. What is the proof for this? So if A by B is equal to C by D, reciprocate it or divide it. So 1 over A by B is equal to 1 over C by D. So that goes to the numerator. B by A is equal to D by C. B by A is equal to D by C. That is B is to A is equal to D is to C is called the inverted. That is B is to A is equal to D is to C. B is to A is equal to D is to C. This is nothing but this property is called the inverted. Now, alternative. So, alternative means according to this property, if A is to B is equal to C is to D, then A is to C is also equal to B is to D. So A is to C is also equal to B is to D. Then it is called as alternative. So let us take the proof for this. If A is to B is equal to C is to D means A by B is equal to C by D. Multiply by B by C on both sides. Just A by B is equal to C by D. Multiply by B by C on both sides. A by B into B by C is equal to C by D into B by C. So that is if A by B is equal to C by D, multiply by, if you multiply by B by C, multiply by B by C, what happens? A by B into B by C is equal to C by D into B by C. What happens? B and B gets cancelled, C and C gets cancelled. A by C is equal to B by D. A by C is equal to B by D. That is called as a alternative, right? So, according to this property, if A is to B is equal to C is to D, then A by C, A into C, which implies what you will get? A into D is equal to B into C. That is, A is to C is equal to B is to D. That's it. Okay, this is called an alternative. Now, next, comparative. So, next one is the comparative. According to this property, if A is to B is equal to C is to D, then A plus B is equal to B is to C plus D is equal to D, or A plus B by D is also equal to C plus D by D. So, that is, if A is to B is equal to C is to D. So, if A is to B is equal to C is to D means, if A is to B is equal to C is to D means, A by B is equal to C by D. So, according to, just add 1 on both sides of equation, you will get A by B plus 1. A by B plus 1 is equal to C by D plus 1. Take LCM, B is the LCM. A plus 1 into B is B, D is the LCM. C plus 1 into D is D. So, A plus B by B is equal to C plus D by D is called an comparative, right? That's it. For comparative, A plus B by B is equal to C plus D by D. Now, next. So, next one is the dividenado. So, according to this property, if A is to B is equal to C is to D. That is, A by B is equal to C by D. Just A by B is equal to C by D. Then, if you get A minus B by B is equal to C minus D by D, then it is called a dividenado, right? Dividenado, right? What is the proof? A by B is equal to C by D. Subtract 1 from both sides of equation, then A by B minus 1 is equal to C by D minus 1. Take LCM, B is LCM. A minus 1 into B is B. C minus 1 into D is D. A minus B by B is equal to C minus D by D. Now, the last property is comparado and dividenado. Comparado and dividenado. So, what is the relation between these two? Now, according to this property, if A is to B is to C is to D, then A plus B is also equal to A minus B is to C plus D is also equal to C minus D, right? A plus B is equal to A minus B is to C plus D is equal to C minus D, right? Or we can also write, bring this to the denominator, or A plus B by A minus B is to C plus D divided by C minus D. That can also be written as A plus B by A minus B is equal to C plus D by C minus D, right? So, that is A plus B by A minus B is equal to C plus D divided by C minus D. Now, prove by comparado. So, comparado, if A is to B is equal to C is to D, that is A plus B by B is equal to C plus D by D, equation number 1 from dividenado. So, what we have, A minus B by B is equal to C minus D by D, equation number 2 from equation 1 and 2, dividing comparado by dividenado. So, that means just divide equation 1 by 2. Dividing 1 by 2, what you will get? A plus B by A minus B is equal to C plus D divided by C minus D. Now, just by dividing equation 1 by 2. Dividing 1 by 2, what is equation number 1? A plus B by b is equal to c plus d by d whole divided by equation number 2. What is equation number 2? We have a minus b by b, a minus b by b is equal to c minus d by d. These two gets cancelled. What we have? A plus b by a minus b is equal to c plus d by c minus d. This is the relation. Just remember the formula. That's it. What is the relation? A plus b by a minus b is also equal to c plus d by c minus d. This is the relation. Now, by knowing all these types of proportion, let us move on to the problems. Let us take an example. First one, problems. Find the fourth proportional of 6, 14 and 15. Fourth proportional of 6, 14 and 15. The fourth proportional is 6 is to fourth proportional. Fourth proportional. So that is 6 is to 14 is to 15 is to x. So what is the fourth proportional? 6 is to 14 is to 15 is to x, right? What you will get? Just that is 6 is to x is equal to 14 into 6 into x is equal to 14 into 15. Therefore, x is equal to 14 into 15 divided by 6. Divide it. So what this is equal to 2 3s are 2 7s are again 3 5s are. Therefore, x is equal to 7 5s are 35. So therefore, x is equal to 7 by x is equal to 35 means the fourth proportional is 35. That's it. Okay. Now just find the fourth proportional of 1.5, 4.5 and 3.5. Right. Now what to find? Fourth proportion of 1.5, 4.5 and 3.5. That is 1.5 is to 4.5 is equal to 3.5 is to x. Just simplify this. That's it. That is 1.5x is equal to 4.5 into 3.5. So x is equal to 4.5 into 3.5 divided by 1.5. Simplify this, right? That's it. So what is this equal to? This is equal to 10.5. So therefore, the fourth proportionate of 1.5, 4.5 and 3.5 is 10.5. That's it, right? So let the fourth proportionate be x. 1.5 is to 4.5 is equal to 3.5 is to x. 1.5 into x is equal to 3.5 into 4.5. So x is equal to 4.5 into 3.5 divided by 1.5. So 3 times it gets cancelled. 3.5 into 3 is 10.5. That's it. Now the next one. Find the mean proportional of 9 and 16. So the mean proportional of 9 and 16. So you know there is a formula for mean proportional. B is equal to root of AC. Here A is 9, C is equal to 16. So this is root 144 is equal to 2. B is equal to 12 is the mean proportional. Or you can also solve like this. The mean proportion of 9 and 16. That is 9 is to x is to 16. Multiply it. That's it. So 9 is to 16 is equal to x into x. X square is equal to 9 into 16. X is equal to root of, this is 144. Square root of 144 is 12. X is equal to 12. That's it. Anyway, you can use the formula straight away or you can simplify like this. Move on to the next problem. Find the mean proportional of 2 and 8. Right. 2 and 8. So the mean proportional of 2 and 8 is 2 is to x is to 8. So that is 2 into 8 is equal to x into x. X square is equal to 16. X is equal to square root of 16 is 4. X is equal to 4 is the mean proportion. So 2 is to x is to 8. That is 2 into 8 is equal to x square is equal to 16 square of 16 is 4 is the mean proportion, right? Now move on to the next problem. Now next problem is find the third proportion. Let x be the third proportion, of between 6 and 24, then 6 is to 24 is to 24 is to 24 is to x. That is that suppose if x is the third proportion, then 6 is to 24 is to 24 into x. So if you simplify, what you will get? 6x is equal to 24 into 24, x is equal to 24 into 24 divided by 6. That's equal to 1 cancel. 6 4s are 24. 24 into 4. That's equal to 96. That's it. So therefore the third proportion x is equal to 96. Now move on to the next problem. Find the third proportion of 3 and 12. Right. Suppose if x is the third proportion, let x be the third proportion, then 3 is to 12 is equal to 12 is to x. Multiply this. That is 3x is equal to 12 into 12. X is equal to 12 into 12 divided by 3. 3 4s are, that's equal to 12 into 4. 12 into 4, that is nothing but 48. That's it. 48 is the answer. Okay. So therefore the third proportion x is equal to 48. This is how we are going to solve the problems based on the problem. These are very simple problems for 1 or 2 marks. Hope you follow, right? That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.